The idea here is to make a curved sensor camera. When you normally look at something, so we have a tree, a bush, and the moon just rose, and it looks big and beautiful. And you're looking at that, and you're just thinking, that is amazing. It is great. So you take your phone out or your camera, and you snap a picture, and you get this little dot. And depending on the exposure, it's blown out, doesn't look like anything. And the disappointment is almost palpable. So when you're looking at the moon in your eyeball, you have, so this is a cross section of your eye. You got your lens here and your pupil. And just a little off center, you got the macula. And so light comes in here, gets bent by your lens, and is then directed onto your retina, and it creates an image on a curved plane. That's a contradiction. There's no such thing as a curved plane. A curved surface. There we go. Talk like less of an idiot. On your camera, however, you have a square flat sensor. And you have a tiny lens. You don't really have a pupil per se, but you do have an iris of a type. And you actually have multiple lenses. And so the light comes in, bing, bang, bomb, boom. You have your focal point. And it creates a flat image on a flat plane. The manipulation of the path the light takes to get it on the flat plane is what's changing the perception, the difference in perception. There's a lot of other factors to this. It's not just the fact that you're on a curved image plane, curved image surface versus a flat image surface. But that's where we want to start. That's where I want to start. Because normally, if you just had a regular simple lens, or a thin lens, depending on, in the books, they always have a candle. Okay, and then you have your focal point, and then you have the image plane. Now they always say plane, but technically speaking, as the light comes through here, it's going to go through the focal point, but it's going to stop short of that focal plane in reality. Now, if this is close enough, and so like a point here impacts this, it gets bent down, it goes through the same focal point, but here it will reach the plane, because just with a regular old lens, it's producing a spherical image, or at least the focus is spherical. By adding the extra lenses, you can flatten the focal plane, which is what you have to do if you're using film or a electronic sensor. What I want to do is keep the simple lens, so no distortions or minimal distortions, minimal material for the light to go through, and alter this. Now, one way to do it is to have a curved back, little holes in there, and then you'd lay a piece of film on there. I'm going to draw this with sprockets, but if we were to do this, I'd probably use 4x5. And you'd have a little vacuum pump that comes out the back. And it would suck the film against the curve, and you could take a picture. That's one way to do it, but you'd have to use film. You could do it with 35 millimeter, but again, I think it would be easier. You wouldn't even have to, with 35 millimeter, you could probably make runners that force it against there, which now that I think about it, that might not be a bad idea, but that would get more complicated. Believe it or not, more complicated than what my thought is. My thought is you take a linear, right now I'm going to be using a linear CMOS. Linear sensor. So each one of those is a pixel, and the one I've got is going to be 1024. 1024 pixels, and I believe the pitch is 12.7 micrometers, or microns. And so anyway, you'd put that at the distance that the focal distance would be. And in this case, we're going to attach it to a wedge. It doesn't have to be a wedge, but this just helps to visualize it. And that wedge, this distance, is going to be the focal length. And what will happen is, as this moves up and down, this is going to keep in the same focus. It's going to keep focus as it goes up and down. Being a curved image, with every part of it being in focus, and then in the computer you'd flatten it. And ideally, that distortion correction would preserve this effect, mimicking your eye. The challenge here is building a rig. So again, we have the sensor, we have it on an arm. Arm is at the focal distance, and then you'd have a lens. And then the arm would have to, for right now, I'm thinking like that, and then just so we'd have the gear, and then we'd have the drive gear, and that would be on a NEMA. That would be on a NEMA 17. And then the sensor, for the time being, I'm going to have it driven by a separate board that'll be fast enough to pull the data off and process it, while the NEMA is going to be driven by a RP4. And I'm hoping that using an RP4, I can try and kind of correlate the incoming data from here to build an image as I go. I'm sure there's other ways to do it, but I'm more familiar with Raspberry Pi. So that's the way I'm thinking. Obviously, this is going to have to be something that needs a tripod. So this isn't going to be, my assumption is best case scenario, the max amount of time I want to spend taking a photograph in poor light, so longer exposure, would be 30 seconds. That's the max. That means every time this takes a step and then does an exposure, the sum or the product of that combination needs to be less than 30 seconds. And so, you know, the smallest step you can take, meaning the maximum number, the maximum resolution in terms of the lines, is going to be 12.7. I don't think that that will be, I believe there'll be diminishing returns at that small of a step size, so we'll go a little bit bigger. I'm sure there's other ways to do it where you don't do a step size, you don't do a step, you just do a constant readout. But just based on my experience and knowledge base, I'm going to try and keep it simpler, where we can do a 1/30th of a second exposure for every step, and then have that stay under 30 seconds, ideally. 1/60th of a second, possibly. The nice thing about photographing the moon or any other landscape object is that typically they're stationary too, so you don't have to worry about that. And the moon is a very bright object. You have to expose similar to daylight for the moon itself. Everything else will be pitch black, obviously. So anyway, that's the idea, and obviously my best thinking is done in CAD, contrary to what everyone says. My doodling is just awful, and sketching is atrocious. And beyond that, well, there's nothing beyond that. It's CAD. It's CAD all the way. So next Wednesday will be the next video, and again, just to kind of force myself to stay on top of things.